of course assignment as well. So all the group is going to do the same assignment, and it will be a group assignment, a project as well. It's going to be a group project, and we're going to sit for mixed semester exam, which is objective, and final exam is also going to be fully multiple choice, right? So make sure that you have you attended all the quizzes, assignment, you submit all the assignment and projects. Do not miss any of them, right? So because those are the things that is going to save your day. Sometimes, our luck is not too lucky. That, the luck doesn't favor us. We just didn't do well in our exam, but at least you have your coursework like assignment and projects to make sure, to actually push you through the course. Okay, that's why do not look lightly on your assignment and project. I know you are very good in sitting for exam, but please do pay attention to your assignment and project. Do not miss the deadline because you're going to submit through the system. The system do not negotiate. See, a deadline is a deadline. They do not negotiate. So if you are late for the deadline, the system do not want to accept your submission. I cannot do anything. You have to start begging, but you cannot beg the machine. It won't respond to you. Right? So those are actually on the course assessment, and our course goal is basically to give you a general overview to the field of data communication and computer networks, and for you to understand the fundamental of data communication and computer networks. That's why you need to look at each of the functionality at different layers. And then later when we go down to the layers, then we will start to appreciate why we want to put them into layers, because it is just like different departments. Okay, so different departments take care of different things. So it's going to make life much easier. And you also need to understand the key role of the data communication and computer networks in providing integration with an organization. Okay, so what are the role that this network is playing? Okay, what can it do? And demonstrate the detailed knowledge of the application of data communication and network technologies. So how they can be used, which is on the application itself. And then today you have actually using a lot of network application. If you look at your smartphone, look at your laptop, okay, and all those applications that you are running, as long as it is involving network, so those are actually the network applications. So you can see all sort of different types of applications that has been made available in today's modern networks. Okay, our policy here is to avoid plagiarism. Okay, so plagiarism is something that you shouldn't be practicing. So I know that getting information from the internet is quite easy, especially with the help of your Google search engine. You can just type a keyword, then we'll probably can give you some information about this and that. So you just have to digest what is being presented to you by Google. That's why you do not just copy and paste directly when you actually do your coursework, such as assignment and project. And that's why plagiarism is something that you have to practice, because it's to a lot of students, taking shortcuts to just do copy and paste. And at the end of the day, you do not really learn much. Okay? So plagiarism is actually talking about your ethical value, about whether you achieve this through your own effort, or you just you just cheat through the process. So it's something that you shouldn't be practicing. So try to avoid any of this plagiarism. So know how to properly quote information from internet sources or from others source of information. And expectations. Okay, so what's our expectation? Well, yes, of course, we expect you to complete the goal as listed and to be self-motivated. Doing online session is not too much of motivation, I know. It can get demotivated sometime, but you have to find ways to, if you need someone to talk to, and then you can ask some questions, try to get yourself motivated. That's why you have groups. You're going to be grouped into different groups, and then you have to talk to your group members, and each of you will have to motivate each others, right? And to complete your assignment on time, to attend classes, to attend online sessions, and to watch all the lecture videos, to come to the class ready to learn and to ask questions. And some of these question, by asking questions, you actually can strengthen your understanding. If you do not know anything, of course, you don't ask any questions. But if you start to know something, then there will be sure a lot of questions that are going to pop into your mind, and then you would like to ask. and you like to clarify. You see. So those are actually the learning process. So I just don't keep quiet. The more you keep quiet, unless you really, can just learn by just listening, then good for you. But I think most people will have problems doing that. That's why sometimes when you come across a certain topics that you do not understand, or certain aspect that you think that they are conflicting, then it's better for you to ask questions. Right? So your task, submit assignment on time, make sure submit assignment and project on time, and then pass the exam. And of course, be serious to get an A. Just don't get a pass, okay? There's no point. So you just need to be an achiever, to do the best, to do your best, and be independent. And university learning is always independent learning. It's adult learning, It's adult learning. So it's no one is going to, asking you, hey, have you done your homework? Have you do your studies and all those things? And no one is going to nag you like your mom. Okay, this is already in the university, so you need to learn how to be independent, and then you must learn how to work with your group member as well. And for this course, you cannot choose a group member. I will be the one choose for you. I will be randomly picked. And the whole idea of this, randomly picked group member is that I want you to meet stranger. If you haven't know all your classmates, then I want you to be able to collaborate with stranger. And then those actually upgrading your interpersonal skill on how to deal with other human beings. And that is actually very important, especially when you go out to work. When you actually join a company, can you choose a colleague? You cannot choose a colleague, You will say, oh, I don't like that colleague. Boss, please fire him. I don't like him. You cannot. You like it or not, you have to work with people that sometimes you don't like them in the first place, but you have to have the skill to how to deal with them so that you can get your job done. So it's not possible for you to like everyone or everyone to like you as well. So but you just need to acquire the skill on how to work together peacefully to achieve the ultimate goal of your task, right? So that's why putting stranger into your group is actually kind of fun. You get to meet different type of people with different characteristics, with different behavior, with different attitude. Okay, so and then what you are producing at the end of the day is going to affect all of you. Okay? It's going to affect all of you. So it's actually a matter of how do you work together and then deal with each other's and then solving the problems that within the group. Okay, the learning resources here, we are actually based on a textbook called the Data Communications and Networks, written by Forozan, published by McGraw-Hill. And there are many editions. I think the latest one is actually the 5th edition. So you can either use the 4th edition or the 5th edition is fine. You can find a book that is good. And if you cannot find a book, I think you can private message me. I will see how I can provide you with some resources. So those are actually the textbook. If you really like to explore more into the topics, so our course is actually based on this textbook. And of course, the internet is actually the great source of information. Like your friends, Google is going to provide you with a lot of information that is coming from different sources, and then they all lead to the same understanding, right? So you can also make use of the internet, and then today's internet are becoming so easily available and become so popular and become so powerful that is beyond what the textbook can offer you. Right? For some old school people, they like textbook, you can go for the textbook, and for some the newer generation, they still prefer to get information from Google. That is fine. You can continue to do that. Okay. So these are the topics. Actually, these are the topics that I actually cover in learning unit number 1. I'm not going to cover it here. I'm going to cover another topic. This one is in your video lectures. So I think I will stop here. I will leave this section to be covered by the video lectures, but I'm going to give you another section that is actually not inside the video lecture. Let's see. Okay. Okay, so yeah, so this is actually for some of the questions about data communications and networks. So when we're talking about a computer network is basically we are trying to get two computers to actually talk to each other. And for a network, it is not started from computer networks. It's actually so many different type of networks. We have telephone networks, which is actually one of the oldest network. The telephone network was designed for the human to communicate, for you to call your mom or call your dad if you miss them. So that is the telephone networks. It's only carry your voice. So the telephone network was first regarded as the world most complicated machine, because it is the world largest machine. It covered the entire world, and that was last time. But today, it is not only the telephone network cover the entire world, but it is actually we have a data network which is much more complicated than the telephone network now, which is not only cover everyone in the world but also cover every device in the world. So you can see the number of participant, or what we call the devices that is in the network, is actually come in billions. So for this computing device to be able to talk to each other, so for example, computer A and computer B, so you will have a sender and a receiver. So the data to be sent from one computer to another computer. So in order for you to send them, so you will need to, have, oops, sorry, so you need to have a transmission media. You need to have a transmission media to interconnect the two computers together, the two machines together, so that they can actually exchange information. They must have a medium to exchange the information or to exchange messages. Okay, to exchange messages. So that transmission media is very important. That is actually used to interconnect the two computers. They cannot just like human, we can just talk using our mouth, and then we can use our voice to talk, and then the other person can just pick up our voice. But for computers, they cannot. They need a transmission medium. But there are different type of transmission medium you can use. I know you may like to say that oh, this is a wireless transmission. Yes, wireless do not have this transmission media, but wireless is one type of transmission media. Okay, so you must first establish a transmission medium, and then from there you will be able to exchange the information. So for two computers to exchange information, they must use the same rules of communication. Okay, for example, I give you a simple example. When you want to talk to someone, both of you must understand the same language, right? So if I speaking German, then you speak English. So the two of us won't be able to communicate because we speak the different language. I do not understand English and you do not understand German. So that's the problem. So in order for two computers to be able to talk to each other, they must run in the same set of rules. And here we call it network protocol. Okay, it's a type of network protocol, and the protocol you can imagine a network protocol is the language for the computer system for them to exchange information. So they must run in the same protocol for both computer, so that they can actually be able to talk to each other. So those are actually the rules. Okay, the protocol define the rules to communicate. Right. So your computer, you can do whatever to your computers, but for your computers to be able to send any messages or any data into the networks, and then so that will be picked up by another computers. So your computers and the other computers must be using the same network protocol. Right? So that is the first understanding that you will have to pick up. And the second part is actually, how does a computer network look like? Okay. Oops. So not enough. Let me see how do I get rid of my screen. Okay, so this is actually how a computer network look like. So you have a lot of different type of computers here. We call it clients computers. You can even connect your printer, okay, to your network. You can even connect your server. You know, a server is just like you know, when you connect to a website. Okay, when you connect to a website, for example, when you connect to Ellipse, you are basically connecting to a server in Unimas that hosted the Ellipse website. So you're connecting to the server. So the server itself has to be part of the network as well. And you can have all the others devices like your laptop or your smart devices. Okay, they're all connected through the wireless network to main networks. So the one in the middle is actually your computer network. So you will have different network equipment such as switches, such as routers, such as modem, all interconnect together to form a network. And then this small network of yours is going to be further connected to the bigger internet. So what is the internet? Internet is basically a network of many networks. So it's a network of many networks. So many networks, when you combine them together, they're going to grow to become a bigger network, right? For example, the network of Unimas connect to the networks in Kuching or in Sarawak. Then the Sarawak networks connect to the one in KL in different states. So they're going to form a nationwide network. So the Malaysian network is going to connect to Singapore, connect to Thailand, and connect to Hong Kong. So this is going to form a bigger network. So as more and more network being connected together, then you can start to see that you have you're going to form the internet. So that's why people call it the internet is a network of networks. So you have different networks connected together that form a bigger network. So your data can pass through this complicated network, okay, and then to reach the destination. That's why the moment when you connected to the internet, you can actually send your data. You can get data from anywhere in the world, as long as that computer or that server is actually connected to the internet as well. Okay, so this is your wonderful experience when you're talking about a network. But they are all started from a small network. It can be as small as just a network having just a switch alone. See, just a switch only. Okay, if you just have a network with a switch, you can already start to create a very simple network. Okay? So this is actually the concept of network itself. Okay, next is actually the TCP/IP model. We're going to talk about more about these models in our learning units, but here I just want to give you an overview. Just now we are talking about what we call the protocol. We're talking about protocol, a set of rules that each computer must follow, right, exactly before they can exchange of data, just like language. If I speak English, you have to speak English. So everyone in the room must speak English so that we can understand each other. So in the internet as well, same thing, you have a very huge network. And this very huge network must speak the same language. So what is the language commonly used for the internet? There is only one language here, which is actually what we call the TCP/IP protocol. The TCP/IP protocol is the only language they use in the internet. Basically, all the computers, regardless of whether they are laptop, they are desktop, they are smartphone, whether they are smartwatch, they all have to use this protocol in order to participate in the internet. So if they do not use this protocol, then they cannot connect it to the internet, right? So that is actually one of the very important requirement. All computers must be running TCP/IP. So that's why TCP/IP is very important in our context here, because literally, practically, we are using TCP/IP every day. Of course, there are some other network model, not only TCP/IP. There are many other network model out there. It's just that they are not popular. If when they are become not popular, then we tends not to study them. Because study for what? You want to study history? Fine. You can go and study them. Because they are become less popular. When I first studied networks, that was 20 years or more than 20 years ago. Then we study other different type of networks like NetBIOS, like NetWare and all the stuff. But in today's context, you don't even see those type of network exist anymore. During my time, yes, those networks still exist. I was still using BIOS network, for my experiment and things like that. But today, no one care about those network anymore. Everyone's focusing on the TCP/IP, right? So that's why TCP/IP is the only language used in the internet in today's modern network. And what is this TCP/IP model? If you look at the different layers here, okay, this TCP/IP here has got like what we call the 5 layers. 1, 2, 3, 4, 5. So it has got 5 layers. So this TCP/IP model consists of 5 layers of network functionality. From layer 1, physical layer, then you have data link layer, you have network layer, transport layer, and you have application layer. And the other computers over the other end must also having the 5 layers exactly the same. See, so your data is going to be passing through these 5 layers. Imagine that if you want to, you want to take a plane, you want to take an aeroplane to fly from KL to Kuching. So you have to follow a series of process, isn't it? When you go to the airport, you have to first register at the counter. When you must register at the counter, then after that, you must check in your luggage, right? You have to check in your luggage. Then you have to go through the security pass. Okay? Then you board the plane. Then when you arrive at Kuching, so the reverse process is being carried out, you see. So you have to depart from the plane. You have to go to security checking. You have to go and collect your luggage. Then you get out from the airport. So it's actually the same process. So you can imagine all these layers are just different processes that your data will have to go through before they can enter the network. Okay? Once they enter the network, once they're being delivered by the network, arrive at the destination computer, for example, arrive here, start sending from here all the way to here. When you arrive here, so the process is going to be reversed. Okay, it's going to be reversed so that you can get back your original data. You are sending a message, so this message will have to be break down by this different process. Then when at the end of the day, when it's arrived at the destination, this process will be reassembled back to its original message. Right. So to you, it's very easy. You just type a message, then you just send the message. Okay, you just send the message. But to the computer system, they do not see it that way. You see, a computer system will actually have to break down your message and then put it into certain form that is actually very easy for them to actually deliver your message. It is not the original message that they are delivering. They will break it down into different format, right? So that they will actually can be delivered through the network itself. And our study is to see how those data is being break down into smaller pieces, and then how they are being delivered in the network. Then after that, at the end of the day, when you arrive at the destination, how they are being reassembled back to its original form, right? So this is something like a quantum leap, So when you actually do, I don't know, you have watched some of this movie that be able to transport you, from one place to another place using a teleporting machine, using a time machine, teleporting machine, where you enter the machine, this machine break you down into, quantum particles, and then using through the quantum particle, they deliver you through the medium. Then over the other end, they reassemble you again. You see, so exactly the same process, but this process here over here is actually much more clearer. You can see the process, and then they are being break down into 5 important layers. Okay, so this is exactly what is happening. So I'm telling you in general only. So we're going to look at the detail in our each of the learning unit. And if you look at this diagram here, you can see that we are going to study the OSI reference model. This is the reference model that everyone refer to. That's why you can see that there has come up with 7 layers, altogether 7 layers. This is the standard. It's a reference model. From the name, you can see it is for reference only. The actual implementation, you may have less than that. You see. So if you look at the TCP/IP model, this TCP/IP model has said it got, some say got 4 layers, some say got 5 layers lah. But actually it's the same one. Okay, so it has got application layer, it has got transport, internet, and then it has link layer. But actually link layer consists of these 2 layers lah. It's actually similar with physical and data link. Okay, so it can be 4 layers. The TCP/IP model can be 4 layers, also correct. It can be a 5 layer, also correct. But you know that the functionality carried out by each of the layer is actually still there. It's still the same. Right? It is still the same. And we're going to cover this in our network model learning units. We're going to look at this in much more detail. And then these are the process. Right? These are the process that your data must go through before they can be sent across the network. But if the data is still remain in your computers, they do not go through this process, they are actually being processed as what you have learned in your computer architecture, in your operating system courses. So those are actually being treated as a file. Okay, those are actually a file. Okay, they are kept in your computers. But the moment when you want to send those files into the network, across the network to another computer in the network, so your files will go through this process. Okay, this 7-layer type of process, or maybe 5-layer type of process, before they can be transported by the network. Okay, so that is the difference. So when they arrive at the destination computer will have to reassemble them according to the reverse process, the reverse order of these layers. Then from there, they will be able to return your data into the original form. Okay, so that your computers, the other computer can see, oh, that is the file that you are sending. Right? But in between, your file has been break down into smaller pieces, into different format, according to the format defined by each of the layers, then only be able to transport by the computer network. So I have to get the ideas. The whole idea I put up this one is for you to get the overall idea of what is the network all about. So it is not just a cable connect to each others and then the data can just deliver, okay, to the other end. So if you look into more details, that's how we have computer A here, sending data to computer B, right? So your data will be going down all the way, right? Will be going down all the way, passing through all the layers, from the top layers until the lowest layers. Then this is going through the cable. You will going through the cable. It's the cable connecting to the network equipment. You have network equipment like switches, routers, and other stuff. So let's say if your computer is connected to a network routers, so at the routers, it has also got layers. You see? At the router, it also got layers, but it will not have all the layers. The router will only have 3 layers until the network layers. So from the network layers here, your data will be, passed up to the network layer and then being processed and then going down again. Because this is just like traffic. So when you send something to someone, okay, you must go through a lot of hands, right? Let's say if you want to send your parcel to someone, the postman will have to pass your parcel from one postman to another postman, isn't it? So when the postman from the postman passing the parcel to another postman, so how do the other postman be able to identify, this parcel is for who? So they must look at the address, isn't it? So when they look at the address, so they have to do this process, reverse the process up to a certain extent that they can read the address. Then they will further deliver the message to the destination. They know, okay, this one belong to which area. Okay, this one should be passed to that particular area. And this area is responsible by this particular postman. So they will pass it to that particular postman. So that's why you can see your data is being passed up and down until the destination. This is computer B. When you reach the destination, the data is going to go all the way up, okay, to be reassembled again. So you can see that the network equipment, such as network routers, they do not have the full stack of the layers. They will only have certain stack of the layers. If you look at switches only got 2 layers on it. Okay? It's the routers. The router has got 3 layers. Switches got 2 layers, and then some of the device only got 1 layer. Okay, so the device only got 1 layers. So your computers will have all the 7 layers, right? The computer will have all the 7 layers, but your network equipment may not have all the layers, right? So I just want to give you the concept. This is just overall. I'm just telling you the overall. Hopefully you can link some of these keywords to what you have already known before this. And of course, we are talking about the TCP/IP model here, which is actually one example of the OSI 7 layers. So in the application layer, we have all this protocol like HTTP. You know HTTP, right? HTTP is actually the protocol used for you to do web browsing. When you open up your web browser, most of the time you see the HTTP, you know, you see the one in front. So you are actually accessing the web server using the HTTP protocol. And then when you download file, it's not called the FTP, like it's called FTP. Okay, sorry, it's FTP. File transfer protocol. And then you can have DNS, small mail transfer protocol as well. So all this all under the application layer. And then of course you have the transport layer. You will have the TCP and UDP. Okay, when you actually do your web browsing, most of the time, if you actually browse a website, most of the time you are using TCP. Then when you're accessing your YouTube, video, then most of the time you are using the UDP protocol. And the underlying network layer is essentially IP. Okay? The important one is the IP, where you have IP addresses, IP address. Okay, you have IP address, so this is come under layer 3. This is layer 3, yeah? This is layer 4, this is layer 5. And then the network interface here, you will cover layer 1 and layer 2 here. So you have the Ethernet, which define different network technologies, or different type of cabling. You can have wireless, you can fiber, you can have UTP cable, which is actually copper cable. So Ethernet is one of the important standard that we use today for our network. Now, of course, we can have frame relay, we can have ATM, token ring. So these are the network tech. Maybe it's not so popular, you never heard of them. Maybe you heard of ATM, but this ATM is not the ATM that you are thinking about. No, this ATM is not the machine that give you money. This is different. This is also not Angkatan Tentera Malaysia. This is actually stand for asynchronous transfer mode. It's another type of network technology. Okay, a very advanced network technology is called ATM. Evolved from frame relay lah. And then token ring is outdated lah. Token ring is too slow. You know, they actually create a ring to allow all the computers to connect in a ring. Then you can pass the data around, but this is too old. And I think today no one interested to build a token ring network anymore, see? Because the performance is not really that great, right? So these are some of the overview lah. Okay, here I just want to give you overview, but we're going to study the detail in our learning unit later on. So I give you some more example. For example, these are the standard. You see, if you look at the Ethernet standard here, IEEE 802.3 is a standard for Ethernet. And what is the Ethernet speed? Ethernet speed is actually started from 10 megabit per second. And then now they have got an improved version called the Fast Ethernet. So Fast Ethernet different standard again, 802.3. Then this one could give you 100 megabit per second. You see, faster and faster. And of course, you are not happy with 100 megabits per second nowadays. Okay, some of you may having Unify at home. Some of you may have more than 100 megabit per second connection. If that is the case, then this fast Ethernet network is not going to be sufficient for your needs, for what you have subscribed for. So you may like to go for the gigabit Ethernet, which will give you 1000 megabit per second. And this is come under a different standard again, right? So for some of you who actually subscribe to, for example, Unify or Maxis Fiber, who actually offer you more than 100 megabit per second, then your home network will probably have to run on gigabit Ethernet in order for you to take full advantage of the internet speed. Okay, of course we have 10 gigabit per second network as well. They come in different standard. It's called a 10 gigabit Ethernet, and we also have 100 gigabit Ethernet, which is quite rare. They're mainly used for the backbone. Even for Unimas campus, we used to be running on 10 gigabit per second backbone, but now we are running on 40 gigabit per second backbone, not yet reaching 100 gigabit yet. But of course, our internet connection speed is not 40 gigabit lah. This is actually the network, our internal networks backbone connection speed is 40 gigabits. And our internet connection speed consists of multiple line, multiple internet gateway. I think a total of 5 gigabit per second for the entire campus, if I'm not mistaken. Okay, and you can see all the other standard as well. Some of the how we call the different standard for the Ethernet. We can call it the 10 best T as well, 100 best T. This is fast Ethernet. 1000 best T is actually the gigabit Ethernet. Okay? And they are using different type of cable. So this is actually what we call the transmission medium that we are using. We are using twisted pair, which is actually copper. If your house still got those old telephone, then you are running, the telephone cable is actually a twisted pair. So a telephone cable is a twisted pair. So inside there you have cable twisted to each other's. But for the one they use for the network one is of a higher quality. They have more pair and more twist. And of course, they're all having a limitation of what we call the distance, maximum 100 meters. Most of the time, 100 meters. For some of the high performance one, they only has got 30 meters only. Right? So different category of cables, they have distance limitation. So these are the things that you need to be aware of. So if you want something better than that, then you don't use the copper cable. This is UTP cable. It's the unshielded or shielded twisted pair. So you don't want to use those cable. You want to change to fiber optic. Okay, if you change to fiber optic, then there is a totally different type of standard. And the performance and distance, they are all different. They are having much greater performance and can cover a longer distance, up to maybe 20 kilometers, as compared to this 100 meters. And this is the fiber standard. Okay, you can see all the different fiber standards. Slowly you will get used to it. You can see all the abbreviations at the end, all the suffix different. So they come in different data rate as well. Okay, they come in different distance, up to 70 kilometers, some of them, depending on what type of fiber they are using. Especially single mode fiber can go very far. Okay. The one that usually we use for buildings one is only the multi-mode fiber, usually 550 meters. But it's still longer than the standard UTP. So these are the fiber optics. We're going to cover this under our transmission media as well. So if you have seen some of this before, then this is how they look like. And of course, today is all of you has been talking about wireless. Some of you, cannot live without wireless. You want Wi-Fi connection. Everywhere you go, you're asking for Wi-Fi connection. You know why? Because Wi-Fi is another type of networks. It's actually called the wireless Ethernet. Okay, you have all this Ethernet. You can have the copper Ethernet, which is using UTP with limitation of 100 meters distance. Then later you can go for fiber Ethernet. The fiber Ethernet can go up to maybe 70 to 100, so maximum 70 to 100 kilometers of distance. So those are for fibers, but those are come with cables. You don't like cables, then you can have the wireless Ethernet. So that's why this is what you call the Wi-Fi. So when you talk about Wi-Fi, this is actually the wireless Ethernet standard. Come in different standard, 11A, 11B, 11G, 11N, 11SE, and the latest one, Wi-Fi 6, is actually 11AX. So when you have the Wi-Fi 6, it will just become slowly introduced into the industry like 2 years or 3 years ago. Now it's become more and more popular. Almost all the wireless equipment that you buy from the shop support Wi-Fi 6. Okay, so you can run at a greater speed. And they're all operating at different frequency here, 5 gigahertz, 2.4 gigahertz. Okay, usually these two, 5 and 2.4 gigahertz. The higher frequency you go, the higher speed you can go. But of course, a wireless network, if you understand properly, then they also come with their own problems. Because wireless, it can be easily disturbed by anything in the surrounding. So when you are doing the transmission, when you have something blocking your signal, so your signal is going to be degrading. So when your signal degraded, then your performance is going to degrade as well. It's the same thing. I'll just give you a simple example. TV remote control. The TV remote control is actually using infrared. See, infrared is also one type of wireless communication. So when you use a TV remote control to actually change your channel, then you can just change it wirelessly, it's no cable connect. But the moment when you have someone standing in front of the TV, then your remote control has no function. See, you cannot change channel. Someone is blocking your signal. See, when someone blocking your signal, you cannot have the communication established. So no function. So this is exactly the same problem that's going to happen to your wireless, to your wireless network as well. See, but it's just that depending on what kind of object that is blocking your signal, some bigger objects then block more signal, smaller object block less, and so on and so forth. That's why wireless is always subject to obstacles. Building, your wall, your roof, humans, your trees. Okay, all those things can actually cause distortion to your wireless transmission. That's why sometimes when you are on the wireless transmission, you do not find that it is actually as stable as compared to as important as reliable as what the normal wire network is going to be. That's why, of course, wireless network give you mobility. The wire network give you reliability and the performance. If you want to have the extreme bandwidth, faster speed, fiber optics. Okay, so here I will just basically give you some overview. Okay, some overview of the things that we will be covering in this course here. And of course, we're going to go through all of them here in each of the learning units to come. So, but I will just want you to be able to see, the bigger pictures. The more you can see the bigger pictures, I think when we go into the detail section, so you won't get lost, you see. So this is the most important things that you won't get lost. And you can still make good use of your knowledge to link everything together. No, Ethernet is not really a device. Ethernet is a standard, but you can have a device that is complying to this standard. Okay, so Ethernet itself is actually a standard. So it is not a device. A device is like switches, hub, routers. So those are actually the device, a physical device that you can see. But each of the network device, they must comply to a standard, right? So they need to have to comply to a standard. So Ethernet is a very popular standard. So if your two devices comply to the same standard, then they can communicate with each other, right? Easily. That is at the lower level, right? But for you to participate in a bigger network, because in a bigger network, you consist of, millions of different network devices, right? Consist of millions of network devices. So they can have different technology, not necessarily only Ethernet. Okay, Ethernet is only for small network. So if you're going to build a small network for your home, for your small office, then most of the time you are going to use Ethernet as the standard. Okay, most of the small network are built from the Ethernet. Then when you connect to a bigger network, for example, to your internet service provider such as Telekom Malaysia, then they are using a slightly different type of network technology. So you are integrating different network technology together. And then from that point onwards, you need to adopt a higher level protocol where all the networks is actually, all the network can actually understand each other's, right? So this is actually happening at different layers. Ethernet is only happening at layer 1 and layer 2. But your internet happening at layer 3 and layer 4. See? Your internet happening at layer 3 and layer 4. So you can see that, your internet is actually running on the TCP/IP protocol, which is more important at the higher layers. So you can be able to actually support all the different type of network technology to allow them to communicate with each other. Okay, so this is exactly what's happening, right? So I think today I just give you some of this overview, overview of the network itself. So I think I already made that video lectures for LU1 available in Ellipse. You can take a look, you can watch it, and we will discuss further next week. Right? Discuss further next week the important point during our online interactive session. All right. So is there any questions before we call it a day? Okay, I think I have some question here. Okay, the difference between internet and internet. Internet and internet. The one with a capital, the one with a small letter, is it? So I think it should be written as the capital. Okay, it should be written as the capital. To be precise, actually they are the same thing. I think there is actually something called the internet, something called the intranet. You see, so this intranet is different. Internet and Ethernet is two different things. Okay, it's two different things. Ethernet is actually the standard at layer 1 and layer 2. Internet is actually referring to the one in the layer 3 and layer 4. Okay, so this internet is actually a protocol. Okay, you're running on the protocol. So it's allowed every piece of network equipment to be able to communicate at that level, layer 3 and layer 4. But for Ethernet, it cannot go beyond if they just solely based on Ethernet standard. It is only for small network. So that is actually the standard for the hardware to at layer 1 and layer 2 to interact on it. But you want to do internetworking, you want to internet, or to say internetwork, interconnect different network together. So you will need a higher level protocol such as the TCP/IP to link them all under the same protocol so that they can actually understand each other. Both are network. I would say different layers of network technologies. Okay, you have to put it this way: different layers of network technologies. That's why you must divide the networks into the layers. So you have to see them from different layers so that you can understand easier. So the lower layer is something that you can see. Okay, something you can see, you can interconnect. Okay, you can touch. But when you go up the higher layers, it is actually something a little bit more abstract, very much like software. Okay, so they must running the same software, something like running the same software to allow them to actually exchange information. Just like now, if I'm using WebEx and all of you must be using WebEx, isn't it? So if you don't use WebEx, you won't be able to receive. You won't be able to be part of this meeting here. See, so exactly this. When you go up, it's actually very much into the software. So Ethernet is actually very much defining the hardware, the network hardware itself. And you can allow different hardware to talk to each other at the higher layers by using the same software. See, for example, you are using a different computer than your friends. You are using a different computer than mine. I'm using a Mac. And you are probably using a Windows. So how can a Mac talk to a Windows? We are totally different type of computers. Why? We are using the same type of software at the higher layers to allow us to exchange of information. Yeah, the internet is at higher layers. The Ethernet is only at layer 1 and layer 2. The internet is at layer 3 and layer 4. Right. So the higher layer one will be able to cover more. I would say cover more. They can support different type of hardware standard. Right. So Ethernet is one of the popular hardware standard. Ethernet is one of the popular hardware standard as compared to token ring compared to frame relay, ATM, those kind of things. Right. Okay, good. I think we will slowly go into this. Today we just talk about the overview so that you get an overall pictures so that next time when we talk about the details, you can relate them. Okay, you can actually relate them so that you can have better understanding. And I always like to give you a bigger picture so that you are not just looking at each of the term, you don't know where this thing came from and what is the relation of this one and the other one. Okay, so I try to give you clearer pictures. All right, is there any other questions? And if you still want to scan your attendance, so I will let you scan your attendance first. see which one. Okay. So this is your attendance. I know you have 2 groups. Okay. I do not know which group you belongs to, but you just scan both lah. Okay. Because I think one group has timetable clashes, and then the other group is the original group, has no timetable clash. I think got only 10 students. The other group has got 25. So it's very difficult to know which is which, but you just scan both. It will make no harm. Okay. Let me see, this one has got how many people? 31 already. This one has got 30. Okay. I think altogether we have like around 40 students. I think not everyone turned up. Huh? And for this course, everything is online. And this is first year. Still consider first year courses. First year courses all conducted online. So any issue concerning the course, you can actually what they call the post in the WhatsApp group. If you have concern about you cannot do the attendance using the QR code, and if you need manual attendance, you have to let me know here lah. Okay, post your metric number here, so I can do a manual attendance for you. Is that all? Anyone? Any more scanning of attendance? Okay, if you have done your attendance taking, I think that's all for today's hour. So tomorrow you will be watching the lecture video for everyone, and then next week we will see each other again at 2 o'clock on Monday online. So the link will still be the same lah, on Ellipse. You just get the online WebEx links from Ellipse. And you have done your attendance, then you may leave now. Thank you very much. I will see you next week.